Hello, this is Shenyang Yuan. My research topic is workflow scheduling algorithm. Workflow scheduling algorithm in a cloud computing environment provide effective solutions for cloud service. However, current scheduling algorithm determine the scheduling plan before task scheduling. It ignores the impact of changes in the scheduling environment during the actual scheduling process and the dynamic change of the workflow task substance path. I studied the above shortcomings of the workflow scheduling algorithms under the cloud computing. First, I analyzed the goals of the scheduling. Classification of the existing scheduling algorithms can be divided into the following categories: static scheduling, dynamic scheduling, central scheduling, distributed scheduling, preemptive scheduling, no preemptive scheduling, online scheduling, offline scheduling. For static scheduling, the scheduling strategy is formulated before the actual scheduling. For the dynamic scheduling, the scheduling algorithm changes with the actually loading situations of the resource service and the network in the process. For central scheduling, the main service is responsible for all workflow tasks and the allocation of the subservice. Distributed scheduling utilize a local schedulers to manage application requests and maintain job states. Preemptive scheduling. This type of scheduling allows interruption in the scheduling process, and the workflow task after the interruptions can be transferred to another resource service. No preemptive scheduling. A workflow task can only be executed on one resource service, and the resource service can be released after the workflow task is completed. For online scheduling, each workflow task can only be scheduled once, and the scheduling resources are immutable. Offline scheduling, when the workflow task arrives, it will not be matched with the resource service first. Instead, the workflow task will be stored and pre-scheduled, and then it will be matched to the resource service based on the pre-scheduled time. Next, I analyze the existing workflow task scheduling algorithm. Most of the workflow task scheduling algorithms in the cloud computing environment are scheduling workflow tasks in the homogeneous and heterogeneous environment. This scheduling algorithm can be divided into two categories: heuristic scheduling algorithm and multi-heuristic scheduling algorithm. Heuristic algorithm is proposed related to the optimized algorithm. Heuristic algorithm mainly include particle swarm optimized, anti-colony optimized, and genetic algorithm. Particle swarm optimized. The dimension of the particle is the particle swarm optimized is the numbers of the workflow task. Each optimized of the particle represents a mapping between the resource service and the workflow tasks. Genetic algorithm is used a modified genetic algorithm to achieve better scheduling resource. Most of the scheduling task scheduling algorithm will produce better initial group to achieve their better resource. Anti-colony optimized. This algorithm is an optimized algorithm based on animal behavior research. It has strong advantages such as the robustness, positive feedback, and self-organizations. Meta-heuristic algorithm. Meta-heuristic algorithm is a promoted algorithm of the heuristic algorithm. It combines the random algorithm and local search algorithm. Meta-heuristic and heuristic hybrid algorithm. Heuristic and meta-heuristic hybrid algorithm are used to solve the workflow scheduling problems. Representative examples include space fit, random, no, round robin, and max to mini. Next, I analyze the existing comprehensive scheduling algorithm. The comprehensive scheduling algorithm is a scheduling algorithm that solves how to arrange production and assumption resource to achieve the research goals. The classic comprehensive scheduling algorithm are quasi-critical path method, base adapter scheduling method, equipment compact method, dynamic critical path method, substantial path method. Quasi-critical path method, the main idea of this algorithm is to find the critical path of the processing technique tree first, and to schedule the process on the critical path. The best adapt scheduling method. The main idea of the algorithm is that when the process nodes meet the immediate construct relationship, the process equipment is searched for the idle time that can be completed as soon as possible for scheduling. Equipment compact method. The main idea of the algorithm is to move the relative processing of the equipment backward and enlarge the idle time period on the equipment so that the idle time period is just suited for the current scheduling process, thereby achieving a compact process on the equipment. Dynamic critical path method. The main idea of the algorithm is to recalculate the path length of each leaf nodes in the processing technique trees, to select the method that can be scheduled for each process, and to dynamically determine the process sequences. Substantial path method. The main idea of this algorithm is to use dynamic long path strategies to determine the planned scheduling process from the set of the alternative process that can be scheduled. Next is the problems and the solutions. I find the three problems here. The first is the impact of the dynamic change of the schedule path in the cloud computing environment on the resource of workflow task scheduling. The solution for this is I proposed a dynamic substantial path drive cloud computing scheduling algorithm. The second is the problem is the impact of the dynamic change of the network band in the cloud computing environment on the results of the workflow task scheduling. For this one, I propose a cloud computing scheduling algorithm based on the network timing bandwidth weight model. The third is the impact of the dynamic change of the resource service state in the cloud computing environment on the results of the workflow task scheduling. For this one, a dynamic cloud computing scheduling algorithm based on the resource feedback are proposed. Next is my project plan. Thank you.